So what we're going to do is take what you just learned, which is how to solve rational equations, and we're going to apply them to some word problems. So with that in mind, every one of these problems we're going to do is going to involve us taking the sentences that we're given and turning that into usually two different rational expressions separated by an equal sign. Okay, so let's start off with the first one. There are 170 calories in 3 peanut butter cookies. How many calories are in 7? So I don't believe calories work in reverse like that. It's not like they cancel out the more you eat. So the thing that we want to figure out is how many calories are in one cookie. Like if I knew how many calories were in one cookie, this would be an easy problem. Okay, so what I would like to know is how many calories per cookie are there? And I'm saying it like that, calories per cookie, because in math, the word per signifies the fraction line. So if I say there are 170 calories in 3 peanut butter cookies, I could say there were 170 calories per 3 cookies. Calories on the top, cookies on the bottom, so calories per cookie. Oh, that's too much. So the next thing that I want to do is set up an equivalent fraction. I'm going to do equal sign. Set up an equivalent fraction for 7 cookies. The question is, how many calories are there? So that's my x. I don't know how many calories there are. There are x calories in 7 cookies. Now, it's not necessary whenever you do these problems to write the unit. You don't have to write the words calories and cookies. It's totally fine for you to just write 170 over 3 equals x over 7. But the reason I'm writing is because I want to stress to you that if I put calories on the numerator in the first one, calories has to be in the numerator on the second one so that cookies is in the denominator both times. You have probably solved problems the way that we're going to solve this one. You've probably done it. Okay? The way that we're going to solve this problem is by doing something called cross multiplication. Cross multiplication is how you can solve this is called a proportion. When you have a rational expression equals a rational expression. Cross multiplication. It is also the way Jesus does math. I'm assuming you're not laughing at that because you don't get it. It's probably over your head. Let's cross multiply. So cross multiply means you take the denominator from the first fraction and multiply it by the numerator of the second fraction. 3 multiplied by x is 3x. Then you take the numerator from the first fraction and multiply it by the denominator of the second. So 170 multiplied by 7. Okay, I have no idea what 170 multiplied by 7 is. So I'm going to come over here. What? 1,190. You are so good at math. I can't believe you got that so quickly. You are such a cheater. I can't believe it. Cool. Now what? Now I'm going to go ahead and divide by 3. That seems like a good idea. So divide 3, divide 3. X equals, that is going to be 3, 9. I'm waiting for the girl with the calculator to speak up. That would be 6 point. So it keeps going, right? 6, 7. There we go. Huh? Yeah, you could if you really wanted to be impressive. You could say 396.66 with the line on top. Like that. 66, that means like repeating. Or if you love fractions, because I know you do, that's 396 and 2/3. That's also fine. Those are all perfectly acceptable ways to write that. Okay? All right, let's move on. Missing sides of a triangle. So a triangle has got 3 sides, kids. Did you know that? Triangle got 3 sides. A Euclidean triangle has 3 sides. So to find the missing side, we're also going to set up a ratio. What do you suppose it's going to look like? You're thinking of the Pythagorean theorem, which is not bad. Not a bad idea. One valuable piece of information that I need to tell you about these triangles is that these triangles are similar. That's the word that is used that means they're proportional, meaning the ratio of this side of the triangle to this side of the triangle is the same as the ratio of this side to this side. That's what is meant by a proportional triangle. And that right there actually is the key to how we're going to set up this problem. 14 over 18 will be my first ratio. The second one will be 28 over x, and those are equal to one another. I used 14 over 18. Would have been totally fine for me to use 21 over 27 too. I could have used either one of those. I don't need both. One or the other will work. And now I cross multiply. So 14 times x is 14x. And then 18 times 28 is, I'm just going to go ahead and work this out. I'm definitely not going to wait for somebody to calculate. Huh? Say it again? 504, that's what I got. 500. Right. And so the next step then would be to divide both sides by 14. And this one comes out, yeah, to be a whole number, 36. 36 is the missing side of that triangle. So setting up a proportion to solve for the missing side of a similar triangle. Not too bad, right? All right, let's get a little more abstract here. You did problems like this in the last semester, but they were quite a bit simpler than this one. 5 divided by the difference of a number and 1 equals the quotient of 10 and the sum of the number and 12. Find the number. This looks like a nightmare. I'm not interested. Hard pass. Next. Well, let's break it down. 5 divided by is pretty easy. 5 divided by. Next is the difference of a number and 1. What does the word difference mean? It means subtract. And what about a number? A number is a variable. We'll call it like x is fine. We can call it n for number. So the difference of a number and 1 means n minus 1. This one seems pretty self-explanatory. Equals. That's the equal sign. What does it equal? Well, it equals the quotient of 10. What does quotient mean? A result of what? Division. So the quotient of 10 and the sum of the number and 12. What does sum mean? Plus, so the number, which was n, plus 12. Find the number. Okay, so when we did these problems just a little while ago, our strategy here was to multiply by the lowest common denominator. The lowest common denominator here would be n minus 1 and n plus 12. But I want you to try to do this one using this new cross multiplication technique. So let's do n minus 1 multiplied by 10. You got to be careful that both the n and the minus 1 get multiplied by 10. So this will be 10 times n minus 1. Okay? Equals this cross multiplication. 5 multiplied by n plus 12. That one's got a little bit of work. left to go on it, but it's not what I would call an incredibly difficult problem. It's just distributive property and some basic algebra. So let's do it. 10n minus 10 on this side equals 5n plus 60. That's a good idea. That was a solid answer. You got good algebra skills. I can tell you've got the best algebra teacher in this room right now.
Totally.
Say it again? Okay, by doing what? Adding 10, that's a good plan. You are so smart. I'm out of space, unfortunately. So 5n equals 70. And then divide by 5. And 70 divided by 5, I think, is 14.
That wasn't so bad.
That's not so bad. I mean, we've definitely done worse things.
But the triangle one, what were you saying about?
On the triangle?
Yeah, knowing which two to, like 14 over 18.
These were the two shortest sides. So I did the two shortest sides as a ratio. It would have been totally fine for me to do like the two medium sides as a ratio too.
Oh, okay.
Any questions about that one? Let's do another one kind of like that. And just like before, we're going to break it down one piece at a time. One piece at a time. Okay, first, if 3 times a number, what is 3 times a number? 3n. Okay. Next is added to 5 plus 5. Is divided by the number plus 9. N plus 9. The result is equals 4/3. Find the number. Let's cross multiply. So n plus 9 and 4 get multiplied. 4 times n plus 9 equals 3 times 3n plus 5.
What's 9 times 4?
Yep, there we go. Distribute. 4n plus 36 equals 9n plus 15. That is a good plan. You are so smart. We could have subtracted 9n too, but then we would have had a negative. So subtracting 4n seems like it's a little easier. Minus 15. Divide by 5. I don't know why I've decided using Halloween colors is what we're doing on this, but there it is. 21 divided by 5 you could leave as 21/5. That would be okay. Or you could divide it out. It would be 4.2. I'll be kind of lazy and do 21/5, but 4.2 is fine if you prefer decimals. Or you could do 4 1/5 if you're a fruitcake. This next problem is actually kind of famous. It was in a movie. I think the movie was Major League. Seen the movie Major League? When they're in the clubhouse and they're supposed to be out playing, but they're stuck on this problem. It's a funny scene. You should go YouTube it. A painter can paint a sign in 4 hours. His assistant can paint the same sign in 6 hours. How long is it going to take him to paint the sign if they paint it together? Yep, to the end. Because 6 minus 4 is 2, obviously. That's how you do it.
I wish it was.
So the way that you're going to answer this problem is by breaking it down into how much can they paint in 1 hour. So if the painter can paint the sign in 4 hours, how much can he paint in 1 hour? He can paint a fourth of the sign. Okay, what about his assistant?
Why does 1 hour matter?
Well, it's like the calories per peanut butter cookie problem. I'm trying to figure out the amount per hour. Like I was trying to figure out the calories per cookie. His assistant can paint the same sign in 6 hours. So how much of the sign can he paint in 1 hour? So how much can they paint together in 1 hour? I have no idea. No idea how much they can paint together in 1 hour. So that's going to be my variable. You can also think of it like this. This guy paints one sign in 4 hours. This guy paints one sign in 6 hours. So if they both paint one sign, how many hours will it take? When you write it like this, it doesn't seem that bad. 1/4 plus 1/6 is not that tricky, right? I mean, we got to get a common denominator to put them together, but it's really not that tricky. If you were super lazy and you're like, I refuse to add fractions together, you could multiply all 3 of them by the lowest common denominator, which would be 12x, like we did on the first set. Like if you were super lazy, you could do that. Well, let's not be super lazy. Let's get the common denominator and add them. The common denominator here is 12. So I can multiply this by 3 over 3. And I can multiply this by 2 over 2. So that would give me 3/12 plus 2/12 equals 1 over x. And 3/12 plus 2/12 is 5/12. So 5/12 equals 1 over x.
So then is it 5x? Wait.
Yeah, cross multiply. Yep. 12 times 1 is 12. X times 5 is 5x. Divide 5. 12 divided by 5, you could leave it as 12/5, but that'd be a little weird. If I said how many hours is it going to take and you said 12/5 hours, that'd be a little unusual. So let's go ahead and turn it into a decimal in this case. This is going to be 2 2/5 or 2.4 hours.
You were close.
2 was close, yeah. Let's do one more kind of like this. Let's talk about the conveyor belt. A conveyor belt can move 1,000 cans of soup to the loading area in 7 minutes. A smaller conveyor belt can move the same number of cans, 1,000, in 11 minutes. How long is it going to take them to move 1,000 together if these conveyor belts join powers for the good of the cans of soup?
Per minute.
Mm-hmm. The one guy can do 1,000 cans in 7 minutes. The one guy. The one belt can do 1,000 cans in 7 minutes. How can I figure out cans per minute? Yep, 1,000 divided by 7. The smaller conveyor belt can move the same number of cans, which is 1,000, in 11 minutes. 1,000 divided by 11. If I use the two of them together, meaning the rate of the first can plus the rate of the second can, how long is it going to take them to move 1,000?
X over 1.
How many cans are they moving? Cans on top and hours on bottom. Together they're moving 1,000 cans, and we don't know how many hours. I can after I add 1,007ths and 1,011ths. Now, finding the common denominator to add 1,007ths and 1,011ths is 77. That is the common denominator. So to get a 77 denominator here, I'd multiply by 11 over 11. And to get a common denominator here, I'd multiply by 7 over 7. So these are going to give me big numbers, but it's okay. This is going to give me 11,000 over 77 plus 7,000 over 77 equals 1,000 over x. And now I can combine them. 11,000 plus 7,000 is 18,000. Now these are big numbers, but don't be afraid. When you're talking about something as important as soup cans, we got to be willing to make some sacrifices.
Super Bowl.
Get out. Cross multiply. 77 times 1,000 is, surprise, surprise, 77,000. Equals, this is really easy, 18,000 times x is 18,000x. You're almost certainly going to want a calculator for this next part, dividing both sides by 18,000. The zeros cancel, and it's 77 divided by 18, but 77 divided by 18 is not the easiest thing to do. So I'm just going to do this in my head real quickly because I'm so good at math. And I have decided that it's 64.27. Is that what you guys got?
64.
Oh man, did I hear you wrong? Crap, what'd you say? Oh crap, 4. That's what I said. That's what I said. 4.27 what? Minutes. So a little bit less than 4.5 minutes, which makes sense. It's less time.
Are you sure it doesn't make more sense if it's 64?
4.27 makes sense because it's faster than the fastest conveyor belt. Even the fastest guy can always benefit from some help. So it's faster than 7 minutes. That answer makes sense to us. Is it repeating? Is it 7-7? Oh yeah, your calculator does an 8 because when it runs out of space, it rounds the last one. Okay. Does anybody have any questions?